So we're looking at file systems. We've talked about disk. We talked about disk fragmentation. We've talked a little bit about how disks work. Now we have to say, well, how's the information, how's it organized on the disk? We talked about the hardware, but what about the software part, or the firmware part? So Windows operating systems support basically two types of file systems. There's the FAT system and then the NTFS. FAT is the file allocation table, and this is what you would use on floppy disk. Also on a flash drive is probably FAT32. Kind of funny to call it FAT, but yeah, that's what it's called. But on these machines in front of us, these are running NTFS 6 probably. NT stands for new technology. Of course, NTFS has been out there for like 15 years. So now FAT was initially designed for really small disks. When I say small, I mean really small, like 316K. That was the first floppy disk. It was one-sided. The hard plastic floppy disks, 1.4 megabytes, and those were FAT32, but still not much data. So it really was designed for smaller drive systems. Now that drives are terabytes in size, FAT just can't do that. What does MS-DOS mean? Microsoft. What was that? Denial of service. Yeah, there it is. Microsoft Disk Operating System. Speaking of bad jokes, how many Microsoft programmers does it take to change a light bulb? No, none. They just changed the standard to darkness. Yeah, why is it called FAT? The operating system keeps track of used and unused allocation units in the disk area called the file allocation table, hence its name. So that little table I had off to the right that said file1.txt, that's the file allocation table. It has addresses on the drive where that file starts. If that table gets overwritten, you just lost all your connection to the data on the disk. Can you get that data back? Yes, but it's going to take a while to have the operating system help you stitch together all the files on your system. When you erase a file on your hard disk, is it really erased? The answer is no. When you erase a file on your system, there's just one bit that gets flipped at the beginning of the allocation unit. If it's 1, it's being used. If it's 0, it's not being used. So what happens when you delete something, you're just changing the 1 to a 0. And that's the only thing that gets changed. The data that was on that sector is still there. Yeah, even after you empty your recycle bin. You have to physically go in and wipe that sector clean. There's a algorithm that the Department of Defense uses, and if you're a contractor for the U.S. government, you have to supply software that when you delete a file, it deletes it completely, so no one will ever be able to read it again, especially with top secret stuff. All right. Now, allocation units, their first bit, I think, typically marks whether they're used or unused. And then at the end of it, there's a number showing the next allocation unit occupied by the file. And again, when you delete a file, it doesn't really get deleted. You can undelete it. There's utilities out there that allow you to do that. You might lose the first letter because of that one bit being missing, but I think that's different now. Even though you may have deleted a file off your hard drive, it's really not deleted. If you're recycling a computer and you're donating somewhere, I would take the hard drive out. I wouldn't leave it in there. I mean, if you really know what you're doing, you can wipe the disk so that no one can be able to read it. Even if you overwrite information on your disk, there's still ways to get the latent image off of that, so you can see what was on the disk 2 or 3 writes ago with really sensitive equipment. Yeah, that's what I do. Is I take a drill press and I punch 3 or 4 holes through the disk itself, destroy the mechanisms. Now, at the end of this string of allocation units, at the end of the chain, you have this whole chain of sectors, right? Could be anywhere on the disk. Finally, you get to the last bit of the file, and then you have this one that says null at the end. Null meaning, hey, that's the end of the file. Great. But there's also at the end, there's a little flag that says 0 and 1. If it's 1, it's bad. If it's 0, it's good. That's where that flag is. Once it's set to bad, it's never going to be used again. The operating systems go, oh, this sector's bad. Okay, I won't use that one. I'll use something else. Is it bad to have a bad sector on your disk? No, it's typical. The newer disks are a lot better, but Even if you have a few bad sectors, there's still lots of good ones. The operating system won't use it again. What's nice about FAT is it's a simple file system. It's supported on the Mac OS, it's supported in Linux, it's supported in Windows. If you need to share data between those three systems or other systems, FAT is kind of like your default choice. It's not very efficient and it's completely unsecure, but it does work. So what a good thing about FAT, it supports partitions up to 4 gigabytes. That's not so great. Now we haven't really talked about what a partition is. Partition allows you to take a physical disk and break it into 3 virtual or logical disks. So if you have this big hard drive and you want part of it to be drive C, another part to be drive D, another part of the disk to be drive E, those are called partitions. FAT can also store file sizes up to 2 gigabytes. Is that enough to store like a movie? Not really. Is that enough to store a couple songs? Yeah. But the file sizes are getting kind of ridiculous lately. You know, you install a game and the main game map thing is 6 gigabytes. So you wouldn't be able to install it using FAT. These are the bad things about FAT. It becomes corrupt over time. It gets fragmented. There's no file security or auditing options. So anybody who has access to the file can read the file. There are no security on FAT disks. You don't have to put in a password. Anyone can read them. Okay, there's no support for long file names, in FAT16 at least. Okay, so the more up-to-date one is called NTFS, so the NT file system. It's native to Windows XP, Windows 7, Windows 8, Windows 10, I'm assuming. And it's designed for the needs of a network environment. Hey, we have a network environment in here, right? Network is, where's all our stuff that we're writing onto our machines? Are they stored on our machines? No, they're stored on a server somewhere, right? H drive, yeah, it's a mythical server. I've tried to figure out where it physically exists, and I found out that it doesn't. It's actually a virtual server. A virtual server lives inside an actual server, but you can have multiple virtual servers on the same actual server. So if you want the server set up for a specific thing like Synergy, you can have a server for that, and on this exact same machine, you can have a different server set up for another type of programs, like what I'm doing here, presentations and stuff. So even servers themselves are being virtualized. Virtual computing is the kind of the wave of the future. Where's your data? I don't know, it's out in the cloud somewhere. Well, where's your server? I don't know, it's virtualized on some actual server somewhere in the world. So I don't know where the server is. It's not here it's not here at school, I don't think. There might be one I haven't looked at, but I'm thinking this is over at the district office. Okay, so if you want to sell to the US government, say you're writing software for the Army to buy trucks, something like that, you need to make sure that your file system is secure enough so that people who shouldn't have access to a file don't get access to that file. This makes file systems really, really hard to set up. So right now, Google and other companies are setting up huge server farms here in Oregon. Anybody know why they do that here in Oregon as opposed to other places?
Because Oregon is the best and we're better than the rest.
Yeah, it's the temperate climate. They don't have to use a lot of energy in the summer to cool down the servers because it's a little cooler. And the power's cheap. We've got hydropower, right? That's cheap power. We got wind farms. Perfect place for, so if you want to work at one of these server farms, you can make a really good living doing that, setting them up, maintaining them, operating them. If you're taking this class, you're on that trail, you know, if you want to do that. I have files that I don't want students in my class to get to, so I've got those on a NTFS file system, and only I can get into them, and maybe the district folks. NTFS Pros, it can support disk sizes up to 2 terabytes. Tera meaning trillion bytes. And it supports long file names up to 256 characters. Now this slide might be a little bit old with Windows 10. Each version of NTFS that comes out is a little bit bigger. Do I like NTFS? No. It's more complex than it needs to be, I think. Now, if you have a Linux box, a Linux has its own file system. And it's a lot more accessible, I think. So what operating system runs the internet? Anybody know? I didn't hear that. The Ethernet is the technology, but what operating system you think? Yeah, that's right. Unix. Unix runs the internet. All the main backbone servers are not running Windows. They're not running Mac stuff. It's Unix. Well, Linux is a flavor of Unix. So the guy who created Linux, the guy's name is Linus Torvalds. You know who Linus Torvalds is? Anybody? The creator of Linux. You know where he lives?
Sweden.
Lake Oswego. He lives in Lake Oswego. Yeah. So if you see Linus walking around, say, hey, nice job with that operating system. Some things you can do with NTFS that you can't do with normal systems is you can actually compress files that are not used very often. This is how the server farms, I imagine, would do that. Here's this file, some yokel from somewhere around the world stored on the server, has never wanted it again, but they have to keep it there in case this guy comes back. They probably, after a while, compress the file and only pull it out as needed. It's got large file capacity, and it can track when people are hacking into your system. You can see who got what files when, because it keeps track of that. Is it fully secure? The answer is no. Now, theoretically, NTFS can accommodate very large files like databases. These huge files that are databases, they're like, internally they have their own file system, but the file itself is really big. 16 exabytes. Well, we have terabytes, and then we have exabytes. So that's 16 quadrillion bytes. If you took maybe United Airlines reservation system database, you might get somewhere close to that. I used to do a lot of database programming, and the largest I ever worked with was, for one database file, 800 gigabytes. And we had to find ways to keep most of it up in memory so that it would function really quick. One thing you can't do is, if you take a FAT16 or FAT32 file system, convert it to NTFS, you can't go back. There's no way to go back to the original file system. So when you install the new operating system, they ask you this question, realize you can't, it's a one-way street. You can't go back the other way. Okay, so that's file systems. The question is, what file system are we running right now? Where would you look for that on our machines? Yeah, let's see if we can find that. So everybody give that a try. See if we can find which file system we're running. Yeah, right there. If you're using Windows, any of the Windows operating systems past Windows NT inclusive, you're using NTFS typically.